Hello, welcome back to my channel, and today we'll be solving Leetcode problem number 476, that is number complement. So the problem statement given here is, given a positive integer num, we need to output its complement number, and the complement is flipping its bits to the opposite. And let's check with it in let's check with an example. So n here is, okay, I did not select that. So n here is 5. Let's take n as 5 and I'll show with 10 even, or any number. Let's take it as 10. So n is equals to 5. What is the binary representation of 5? It is 1 0 1. Flipping its bits means just change the ones to zeros and zeros to ones. So this should be 0, this should be 1, and this should be 0. So this binary number is equivalent to the number 2. Let's take an example of 10, or we so the binary representation is 1010, and by flipping its bit we will get 1010, and this representation is 5. So this is simple problem. We just need to convert this to a string and store the binary bits in opposite direction. So if we have 5 as a number, okay, I'll just erase this part so it gets better. Okay, this should be erased, and that should do. So if my binary number is 5, so what was my binary representation? It was 1 0 and 1. So we'll just extract the last digit of it and we'll store it in opposite direction in a string called sum. So this will store 1. So I extract the last digit and store it, and I extract the second one and I store it, and I extract the third one and I store it. So my sum will be having 101, and then we'll just convert this to an integer and print it. That's it. That was the whole intuition behind this problem. So let's see how we are doing it. So we are just taking a sum empty variable which will be storing our reversed string or the reversed binary bits, and then we'll be iterating over the nums or the num which is given to us, and we'll extract the last bit. And how do we extract the last bit? It is num mod 2 will give me the last bit. So if it is 101, num mod 2 should give me 1, and we'll add this 1 to the sum to our answer, that is this. So 1 will be added here, and remember that we need to reverse the string. So instead of reversing, we're just adding it in a reverse manner. That is, we are not simply doing sum plus 1. If it were to be sum plus 1, if we be doing sum plus 1, sum is equals to sum plus 1, then this would have given us 101 exactly. Here we cannot figure out the difference, but if we take an example with another number, let's take it as n is equals to, I don't know why the eraser keeps stops working. Okay, let me just erase this again. So if we take n value as, let me take something different. So that should be n is equals to 6. N is equals to 6, and what is our value? 1 1 0. This is a binary representation of 6. If we now flip the bits, what is it giving us? 1 0, okay, sorry, 0 0 and 1. This is our flipped bit representation. And what is this number? This number is 1, so we should be getting 1. Now if we were to do it in a standard way, that is sum plus 1, so we would have been just extracting this part and we would have been adding this. So now we would be getting 0. This is our last bit, so we are getting 0 here, and we are adding sum plus 0, so we would have been getting this. Now we are extracting this, and now we are extracting this. So we would have got some different number. So that is why we are just doing sum is equals to 1 plus sum. So this would give me a reverse string as well as the complemented integer that we want. So if the number is divisible by 0, we are adding 1 to it. Why? Because we want the complement. That is why. So this should do it, and this part is the XOR part. So we could simply write num is equals to, so this could be written as num is equals to num by 2. This would do the same thing. Okay, this should be num, not num. So this and this will do the same operation. It's just that bit operations are faster. So that is why I've done this. And this part is important because stoi is a C++ template that will return us the string to integer. So my reverse string is 001, and this reverse string's integer value is 1. So this should give me 1. So how we are getting this? We are doing it by stoi sum, and 0 is the starting index of the sum. So from where we are wanting to convert it, from the 0th index. And what is the base? The base is 2. So if you want the stoi to perform from binary to integer, so we need to write 2. If you want from 10 to some base, then we can write 10 as well. And if you want from hex, then we can write 16 as well. So now let's run this code, and this code is getting accepted. Let's just use some sample test cases as well, and this is getting submitted, and this should get accepted as well. Okay, this is getting accepted as well. And that was it for this video. Thank you for watching.